research review. This may seem like an odd one because it's like 4 years old, but you know, we're here. So this is SynLapse, technical details for a critical Azure Synapse vulnerability by Zach Pahima. So I don't know what this is about, to be honest. I think it's probably interesting though, right? I looked at it a little bit and think it meets the requirements of what I was looking for, which I can't really talk about what I'm looking for, but we'll get into this. One attack vector closed, additional hardening is recommended. I'm sure it's been hardened since then. This blog describes the technical details of SynLapse in continuation to our previous blog. We waited to publish until now in order to give Synapse customers time to patch their on-premise versions and reconsider their Azure Synapse usage. Microsoft has implemented several improvements as they continue to work towards comprehensive tenant isolation. Cloud moment. Orca security researcher Zach Pahima is credited with discovering SynLapse, a critical... Wow, this is from 2022 and they still have the long dash. That's really funny. A critical Synapse analytics vulnerability. Actually, I wonder if that's from... whatever. In Microsoft Azure, also affecting Azure Data Factory. It permitted attackers to bypass tenant separation while including the ability to obtain credentials to other Azure Synapse customer accounts. Control their Azure Synapse workspaces. Oh no. Execute code on targeted customer machines inside the Azure Synapse Analytics service. Whoa. Leak customer credentials to data sources external to Azure. Alright, I don't need an ad hoc for... or an ad lib for each... Alright, knowing nothing but the name of an Azure Synapse workspace, here's how an attacker could leak a victim's credentials entered in Synapse. Okay. Dude, is this the POC video before we even have an explanation of what Synapse is? Maybe they could have. Alright, whatever. What is Azure Synapse Analytics? Azure Synapse Analytics imports and processes data from many customer data sources, e.g. Cosmos DB, Azure Data Lake, and external sources such as Amazon S3. Each Synapse instance is called a workspace. To import and process data from an external data source, a customer inputs credentials and relevant data, then connects to the source via an integration runtime, a machine that connects to many different data sources. Wow, what an interesting threat model. Integration runtimes can either be... Yeah, I mean, that sounds like a good place to party, you know? Integration runtimes can either be self-hosted, nice, on-premise, or hosted in the Azure cloud via... So it seems like you might be able to self-host it and try to get access to some of the binaries used to back all of this, which would be fun to take apart. Right? That would be fun, right? Right? Via the Azure Data Factory integration runtime. Cloud-hosted Azure IRs can also be configured with a managed virtual network VNet to use private endpoints for external connections, which can provide extra layers of isolation. So yeah, if you're hooking into a DB that's only accessible on the VNet, man, I haven't thought Azure thoughts in how many months clean am I? 3 months now by this point almost. Oh, 3 months Azure clean. Let's go. I will be relapsing soon. SynLapse discovery timeline. TLDR, over 100 days for a final fix, 3 patches. The first 2 were bypassed. Their certificate to the internal control servers was only revoked after 96 days. Nice. Okay, they actually got paid. That rules. Sorry. And this is this is old MSRC. But new MSRC, they pay so much more stuff now. So that's good. I should go hack Azure, right? I should do that, right? Right? No? Okay. January 4th. The Orca security research team disclosed the vulnerability. I don't care about the timeline. Let's see. They've reported it. MSRC got back. That's a reasonable amount of time. Let's be real. Nice. They tried to patch it. Bypass the patch. Nice. 60K. Nice. That's a pretty good deal. Yup. Could have been 0, you know. More bypasses. Microsoft. And then they have fun. Alright, how critical was SynLapse? SynLapse enabled attackers to access... Oh, nice, empty bullet point. Is there secret hidden data here? They've got the secret bullet point where the secret bullet... Aww. That's WordPress. Ew. Is it? Nasty. Okay, sorry. Yes, so from the name of the workspace, you could do bad things from an internal Azure API server. So it sounds like maybe a confused deputy or something. We'll get into it. Gain authorization inside other customer accounts while acting as their Synapse workspace. We could have accessed even more resources inside a customer's account depending on the configuration. Wow. Leaked credentials, customer stored in their Synapse workspaces. Oh no. Wait, I gotta stop throwing ad-libs on each bullet point. My bad. Communicate with other customers' integration runtimes. We could leverage this to run remote code on any customer integration runtimes. Take control of the Azure batch pool, managing all of the shared integration runtimes. We could run code on it every instance, and then the secret bullet point that they had to remove because the impact was so severe that John Microsoft himself would have come down their chimney and wasted them. How did Orca Security discover SynLapse? 1. The RCE. Researching self-hosted on-premise integration runtime, I found a shell injection vulnerability that leads to an RCE. Nice. And the magnitude Simba Redshift ODBC connector used by Microsoft software. Wow, okay, so RCE in a database connector. Imagine that. Okay, and they're like reverse engineering the native binaries. I just assumed that... I don't know how I feel about all this. The shell injection was found in the SAML authentication plugin of one of the connectors. The vulnerable code was supposed to launch a browser, but did so with a shell command vulnerable to an injection. Yeah, that's funny. That's a pattern that has been seen before. I may have seen it recently, and it was... Oh, okay. It's worth noting that following this, there were 4 CVEs issued all with the same payload. This could be exploited by setting up an external data source with the following malicious OBDC. So there's your driver, and then where's the command injection? Here we go, in the login URL for that setting of the... Okay, yep. Using this, I can execute code on myself, or rather my own integration runtime, which is a virtual machine owned by me. Not very interesting. So yeah, so this is like that foothold into the like data plane aspect of it, and then you can try to pivot into like shared resources and see if there's like service accounts that let you fiddle with everybody's everything. I think that's where we're going. Getting to a shared runtime. Integration runtimes are the machines that connect to external sources and process data. There are 3 types of integration runtimes in Synapse. One is self-hosted on-premise, and Azure hosts the other 2. Self-hosted IR. Any Windows machine doesn't have to be in Azure VM after install of the Sure software. Sures are dedicated to a single customer by design. Azure IR without a managed virtual network. Default cloud-hosted Azure IR, a pool of machines shared by multiple customers to execute their pipeline activities. Okay. Azure IR with a managed virtual network provides a dedicated container that is not shared across multiple customers. Okay, so can we target this one and pivot into other people's stuff? So when you set up a runtime in your workspace, you'll come across these options. Yeah, I'm sure they're... The Azure integration runtime presumably shared by more than one customer, and the self-hosted one, which is the one we've already researched as it runs on my machine. They both support the same features. Now, when you try to use an OBDC connection and you attempt to choose an integration runtime, Synapse won't allow you to choose an Azure-hosted one, probably for security reasons. But if you perform the same request but change the name of the integration runtime from my own integration runtime 1, which is my self-hosted runtime, to auto-resolve integration runtime, which is the default Azure integration runtime, it simply works. Okay, nice. So now we have RCE on a shared Synapse integration runtime owned by Azure. Yeah. Then again, the code execution context shouldn't really have high permissions, nor should the machine have any special privileges. I'm sure there's no service accounts. Remember, all that the integration runtime does is connect to a data source and do a bit of processing. The problem should have stopped there. It didn't. Shared runtime permissions, NT authority system ring a bell. Nice. Okay, so they can party on the box itself pretty hard, and then loot it, and then see what they can talk to. Our code is executed in a process called task executor. I just dumped it memory using proc dump, and was amazed to find plain credentials and tokens belonging to multiple companies. Wow. One was a token to Microsoft's own account and another data analytics service, all of which are now expired and revoked by Microsoft after our report. Here's a sampling of users Orca was able to leak this way, censored for privacy purposes. Yeah, because it's a fun box to party on. The certificate and internal Synapse management server. Wow. This is not over. The shared integration runtime contained a client certificate used for authentication in front of an internal management server. Using that certificate, it could access its configuration data and tasks. Wow, being able to like loot the centralized task DB is for something like this. That's a pretty cool bug. I'm sure people have found things like that in other products that are like conceptually similar, but that definitely sounds impactful. Why is that a problem? The management server can do much, much more than just show the integration runtime's configuration data. Oh, wow, okay. The server's API permitted querying integration runtimes in other workspaces, as well as obtaining of Synapse workspace identities belonging to other customer accounts. The latter opens the door to perform almost every action imaginable in any customer Azure Synapse workspace. Moreover, by combining the RCE and the API server's communication ability with other integration runtimes, we could have executed code on any integration runtime, given only the name of a Synapse workspace. Okay, interesting. So it's not like it has some like centralized state that could be listed and be like, who am I pivoting into? So you actually need to know the name. This could be done by executing code on another user's integrations runtime or on the shared integration runtime in use, then dumping memory of the process that was handling external connections. The memory dump includes credentials to external database servers. Wow. External databases, servers, Azure services, and just about everything else. So it's not like they break down. I would like to see a break, like a. I want to understand all the identities, but I don't feel like we're given a great breakdown of all the identities in play. Like, there's the certificate that you can use to talk to the internal service, and it's like, what identity? Like, what cloud, what Azure-owned identities are in play here? Like, it's nice that we're partying on a box with other dudes on it, but, like, what about all the, like, Azure-owned identities, and can we get, like, a clear separation and, like, here's this Azure identity, here's what it can do, here's this one, here's, that'd be... Now armed with these abilities, we could also leak the most sensitive data saved in Synapse, user credentials for external data sources. Yeah. I wonder if those... Did it support... Alright, whatever. We had every integration runtime in Synapse workspace in the palm of our hands. You can imagine how destructive this ability could have been in the hand of attackers. Here's what the integration runtime RCE looks like. Yeah, so... They're pointing it at a workspace name. Oh, is that... What? Well, I believe that this is what it looks like. Yeah, look at that, a shell. Okay. Main flaw, enabling access to a Synapse client certificate with full permissions to a powerful internal API server. Okay, so that's like the core identity that's being exploited here. It's worth noting that the major security flaw wasn't so much the ability to execute code in a shared environment, yeah, but rather the implications of such code execution, yeah, that needs to be isolated better. More specifically, executing code on the shared integration runtime exposed a client certificate to a powerful internal API server. This enabled an attacker to compromise the service and access other customers' resources. Solving this entails making sure that the shared environment doesn't contain the said certificate or reducing the certificate's permission. Wow, that's sad when... this is helpful for Azure context as somebody that has different cloud thoughts as far as how like internal cloud service level identities work. It's cool to see cert-based auth, I guess. I don't know. Yeah, because that really is popular for Azure suppose. That makes sense. Okay, that actually makes sense to me now, yeah. I haven't thought Azure thoughts recently, which, God bless. The fix. How did MSRC fix SynLapse? Not very straightforward. You'd expect them to delete the certificate from the server as detailed above or run in different permissions. They've tried something else. Attempt number 1, no ODBC allowed. Great. Our RCE uses an ODBC connection string. MSRC tried to prevent an attack from using the ODBC connector on a shared integration runtime, so when you try to pass it to your request, you'll receive not supported. The ODBC connector is called generic ODBC in the request payload, so it seems like their patch works. When I tested it, I found a problem. When I decompiled the DLL responsible for the connector is called some nice please be .NET, please be .NET, please be .NET. I found the following piece of code. Nice. What are they up to here? Even without diving too much into implementations, you can see that generic ODBC is a generic ODBC connector, but so are Informix and Microsoft Access. They both work with OBDC connection strings that bypass the exact same payload, but the connector type being Microsoft Access instead of ODBC. Great. Attempt number 2, no generic ODBC allowed. We reported the bypass to Microsoft and waiting for them to patch the underlying issue. They blocked Microsoft Access and all of the similar connectors, leading to generic ODBC connector. The problem, they left a connector named generic ODBC partition open. This one, although not as straightforward to read into, eventually leads to an ODBC connection being created. Okay, so they're able to reach the same sync. So again, the same exact payload, except... Wait, so they didn't even patch the driver? What? Like, the RCE and the driver, you'd think that, like, if they're going to try to fix it in the worst spot to fix it. Alright, whatever, man. Attempt number 3, so close. This one is actually a successful attempt by MSRC, sort of. That's strong. They disabled anything leading to ODBC except for some connectors that have to use ODBC but construct their own connection string in a manner that is not completely controlled by the user. The method in which they construct an ODBC connection string looks like this in the Amazon Redshift connector. So they've got code. Wow, this is a way to have code. Every connector implements a function called build connection strings, which is called upon, you guessed it. So are you able to like taint it and get some semicolon injected in there or something and add a parameter? I went through all the connectors and make sure that every build string is implemented safely. And sure enough, in the Salesforce connector, let's see, are we constructing a string and able to get a semicolon through? Can you locate the problem? Can I read this code? The whole point of implementing build connection string is to make sure the OBDC connection string is restricted to be a safe connection string with hard-coded attributes that ensure no one uses a malicious driver or any other attribute that might make the platform vulnerable to an attack. Well, this build connection string implementation is not very good. The Salesforce connector supports a property called extended properties, so I'm guessing is that, yeah. This is an OBDC string converted to a dictionary containing keys and values, which will just be assigned to the main ODBC connection string. Okay, so by transferring the Salesforce connector payload, adding these extended things, only one catch here. The catch, it didn't work, or rather, it worked on my integration runtime, but not on the shared instance. MSRC was doing patches and mitigations at the same time, and probably somehow disabled the access to the vulnerable feature in the Redshift connector. I thought this was the Salesforce connector. What I tried to do was to find another vulnerable connector installed and exploit it via the full ODBC access I had just acquired again. I found more vulnerable. In the driver itself, or the not the, like, what do you call it? It's not a driver, but like it drives the. It's not a system driver. In this, yeah. What do you call that? Vocabulary is very important. Right. So yeah, RIP, they patched that, which still is not, it's, I'm sure if you went looking around, there's a lot of functionality here that could probably lead to shells on here again. Fixing the root cause. When reporting the issue, we suggested Microsoft implement a few mitigations, mainly a sandbox. Move the shared integration runtime to a sandboxed ephemeral VM. That means that if an attacker could execute code on the integration runtime, it is never shared between two different tenants. Great idea. Limit API access, implement least privilege to the internal management server. This will prevent attackers from using the certificate to access other tenants' information. Also a great idea. At the beginning of June, Microsoft shared with us that they've implemented all our recommendations, and Synapse integration runtime is now using ephemeral nodes and scoped low privilege API tokens. Break back in and validate it, lol. Oh wait, the service probably doesn't even exist in the same state. It's been 4 years. In light of this information, we now believe that Azure Synapse Analytics provides sufficient tenant isolation. As such, we have removed alerting on Synapse from within the Orca cloud security platform. Microsoft continues to work on additional isolation and hardening. SynLapse and previous critical cloud vulnerabilities such as Azure AutoWarp, AWS Superglue, and AWS Breaking Formation show that nothing is bulletproof, and there are numerous ways attackers can reach your cloud environment. They haven't earned the plug, I'm sorry. But this guy, I don't know how, Sock Fahima is a cloud security researcher at Orca Security. Follow him on Twitter. Whoa, you could do that. So yeah, this is a pretty sick bug. I like it because it involves taking that. Well, I like it. Okay, so number one, let's think about great things here. Like, I love that model when there's like a self-hosted version and then a cloud-hosted version, and you can take apart the self-hosted version and then throw that at the cloud-hosted version, especially when it's like, I'm actually able to get command execution. It's like, oh, haha, it's a shared tenant. It's like, oh, there's other people's data here. Or, oh, it's a cloud tenant. Maybe it's isolated. Maybe even like this one, the isolated one, does it still have any cloud credentials? Because they're like, this is a cloud service. Maybe we consider this part of our data plane, or it can talk to the control plane in such a way that's dangerous, or creds that are overscoped that allow it to pivot into other resources. Very interesting. Or even how it gets talked to by front-end APIs can be interesting. Yes. Let's see. Let's check research reviewed format. Yes. So how can this generally be applied to BB? Yeah. So if you want to research like Azure stuff, I think this was really helpful. Kind of understanding how those service accounts do auth, like certificate based. Understanding how the common patterns for Azure stuff is shipped is cool. And then just this model of being able to take a self-hosted version, tear it apart, and then throw it at a cloud version rules so much. Why did this work? There really weren't a lot of defense and depth controls that should have been implemented by Azure on the shared version of this service. That's crazy. Further research. Yeah, I mean, if they're still... Alright, so this is, again, 4 years old, but I don't really believe in sandboxes. Like, it's not a sandbox. If you're like, yeah, we sandboxed it, and then you get in there and you're like, dude, I can just step out of this. Or it's like, oh yeah, okay, but you put gigacreds inside the sandbox. And then limited API access, it's like, what does that even mean? You know, it's like, they tried, but did they do it right? So being able to break back in, so, you know, I'm sure there's all kinds of crazy things going on. This is like complicated code. There's maybe like look for file IO primitives and try to get some sort of like arbitrary file right, or even a way to leak files off of it, especially if you kind of have the idea of where credentials might be stored. And it would be interesting to try. I don't even know if this service exists anymore. Let's see. Azure Synapse. Is it still... Oh, man. Yes, it looks like it's still a thing. But, oh, migrate to Fabric? What is that? Is that the new... Yeah, I don't know. Regardless, there's, you know, interesting things to do there. More code review to be performed. Rating, I rate this one pillaging the shared state out of 10. And conclusion. Pretty interesting bug, pretty good write-up. It's cool that they were able to pivot and show actual impact on the cloud deployments, and I mean, real serious impact. It's cool they got paid, and overall, worthwhile write-up. Definitely interesting for those cloud hackers out there, and it is interesting to see as somebody that's less familiar with how Azure solutions are engineered under the hood. Surprised by kind of the lack of defense and depth, but that might just be how they do things. I don't know. But yeah, this research is officially reviewed.